This video is going to be an introduction on something called electron configurations, which all that is where electrons are located in an atom. So electrons will be important in this class because electrons determine what elements react with each other. So the nucleus was involved in nuclear reactions. We're going to be more concerned with chemical reactions which involve electrons. So it's important to know where they're located. That will determine how elements react with other elements. So for example, two hydrogens always combine with one oxygen, and the reason is where the electrons are located. So you've been taught probably in the past that there are energy levels of electrons. Okay, that's pretty accurate. There are 7 different energy levels. So just number those. The closest one to the nucleus is numbered 1, 2, 3, 4, 5, 6, 7 as we get farther from the nucleus. And electrons are moving at the speed of light or so around the nucleus. Now, we don't know exactly where an electron is at any given time, but we have an idea of the probability of where it's at. So there are certain locations that electrons are in. So here's the kind of general arrangement of the electron cloud. So there are energy levels, and there are 7 of them. We'll number them 1 through 7, again, from the nucleus out farther. There are things called sublevels within energy levels. So it's kind of like you have a school building. Within a school building, there are classrooms. Within sublevels, there are things called orbitals. Okay, an orbital is a little spot that holds electrons, and it holds 2 electrons. So it's kind of like saying you have energy levels like a school. Sublevels are like a classroom. Orbitals are like a table that holds 2 students, or a table that holds 2 electrons. So each orbital holds 2 electrons. So there's 3 different breakdowns. Okay, so we'll kind of go through this. The first energy level, the one closest to the nucleus, is the smallest. And all it contains is an S sublevel. Okay, there's not a P, a D, or an F, but there is such a thing as a P, D, and F sublevel, but it's only an S sublevel. S sublevels are spherical in shape, meaning electrons are traveling in a sphere pattern. That sublevel has 1 orbital. The sublevel's got 1 orbital. All right? And that 1 orbital holds 2 electrons. So the whole energy level only has 2 electrons. That's all that's in the first energy level. So hydrogen and helium are the only elements that only have 1 energy level. The second energy level, a little bit bigger, a little farther out, has an S sublevel and a P sublevel. Okay? In the S sublevel of the second energy level, there is again 1 orbital. That 1 orbital has 2 electrons in it. Again, an orbital holds 2 electrons. The P sublevel, sorry about the shine here, the P sublevel has 3. Write that a little bit lower for you. P sublevel has 3 orbitals. And each orbital holds 2 electrons. That's a total of 6 electrons. So the whole energy level, whole second energy level holds a maximum 8 electrons. Could be less than that, but it has 8 maximum. 2 are in this sublevel, the S sublevel. 6 are in this P sublevel. Third energy level is a little bit bigger. Okay, third energy level has an S, a P, and a D sublevel. So it's got 3 sublevels, S, P, and D. Same thing as before, just like an S sublevel up here has 1 orbital, an S sublevel in the third energy level also has 1 orbital, which holds 2 electrons. The P sublevel has 3 orbitals, just like the P sublevel up here did, which holds 6 electrons, and the D has 5 orbitals, which hold 10 electrons. So your third energy level is much bigger. You've got 2 plus 6 plus 10 has a total of 18 electrons in that energy level. Again, 2 of them are in the S sublevel, 6 of them in the P sublevel, and 10 of them in the D sublevel. Your fourth energy level has got an S, P, D, and F. It's even bigger. Okay, again, the S has 1 orbital. The P has 3 orbitals. The D has 5 orbitals. And you can probably guess that the F has 7 orbitals. Again, each orbital holds 2 electrons. So this one has 2 electrons. P has 6 electrons. D holds 10 electrons. And the F holds 14 electrons. So your total electrons in the fourth energy level would be 2 plus 6 is 8, plus 10 is 18, plus 14. Total is 32 electrons in that energy level. The fifth energy level, sixth energy level, and seventh energy level we'll get to later. Okay, but they all have essentially S, P, D, and F sublevels. For right now, we'll worry about the first 4 energy levels. So again, every energy level gets bigger. Every energy level gains a sublevel. So first energy level has only an S sublevel, which holds 2 electrons. Second energy level has an S and a P. This holds 2, that holds 6. So 8 total. Third energy level has an S, P, and D. This holds 2 electrons, 6 electrons, 10 electrons. So electrons tend to fill in order a little bit. So real quick, we'll do what I call an electron configuration. Move my sheet up. So electron configurations tell the energy level electrons are in, numbered 1 through 7, the sublevel they're in, and the number of electrons in each one. So, for example, you're going to see, let's go down here. We'll say this. You're going to see something like this, 1s2, or you might see 1s1. 1 means the energy level electrons are in. That's the energy level. So the electrons are in the first energy level. S is the sublevel. Remember, you have S, P, D, and F for sublevels. And the 2 is the number of electrons in that sublevel. 2 is the maximum in an S. Now, you could have only 1 electron in there if we're talking about an element like hydrogen. So energy level, sublevel, you say this 1s1. Okay, if there's a 2 there, you say 1s2. You don't say 1s squared, you say 1s2. Again, 2 electrons, first energy level, S sublevel. This would actually be helium. It's got 2 total electrons. Both electrons are in the first energy level. They're in the S sublevel, and there's 2 electrons in there. If we were doing the third element, lithium, which has 3 electrons. Lithium has 3 electrons. You would say the first electrons are in the first energy level. The S sublevel, because it's the only sublevel in the first energy level, and there's 2 electrons in there. Now, lithium's got 3 total electrons, so the first energy level is full. There's no P sublevel. So then the next electrons go in the second energy level, S sublevel, there'll be 1 electron in there. So lithium's got 3 total electrons. These are called its valence electrons, its outermost electrons. So you say this 1s2, 2s1. All right. If we were doing beryllium, which has 4 electrons, this would just become 2s2. 1s2, 2s2. 2 electrons there, 2 electrons there. Let's do boron. Okay. So boron is element number 5, has 5 electrons. Okay, it's got 5 electrons. So its first electrons go in the first energy level, S sublevel, and it can hold 2 electrons in there. Still have 3 electrons left to place to get to 5. Well, the second energy level then starts to fill up, S sublevel, and again, the S only holds 2 electrons. So we've used 2 electrons there, 2 there. Remember then, the second energy level also has a P sublevel. So also in the second energy level, so you still put a 2 at this. In the P sublevel, boron would have 1 electron. So it's got 2 electrons here, 2 in the second energy level, S sublevel, 1 electron in the second energy level, P sublevel, for a total of 5 electrons. Again, these are considered its valence electrons because they're both in the second energy level, its outermost energy level. So it's got 3 valence electrons. Those are the ones that are important for rounding. You're going to try and write configurations for probably these 3 right now, and argon. See if you can write electron configurations for those.